Hey guys, today we're going to do notes over radian and degree measure, just understanding the differences in those. So when we start with an angle, we have an angle and it has its initial side right here. That's where we're starting from. So we call that the starting location. And as you rotate it, we always rotate counterclockwise. And we end up with our ending point, and we call that the terminal side. And so that's our ending location. I did not write that very well, sorry. Okay, we use different Greek letters to name an angle, so we might name it with the letter theta. We call that theta. We use Greek letters. We also use the Greek letter beta. Sometimes we use the Greek letter alpha. Those are ways that we name angles a lot. All right, let's move up a little bit. All right, sometimes we use an angle on a coordinate plane, like this one down here where you've got your x-axis and your y-axis. The vertex will always be located right here at the origin. And we always think of this side right here on the positive x-axis. That would be our initial side. And we're, again, rotating it counterclockwise, so this would be our terminal side. And if we go counterclockwise, we think of those as positive angles. If I were to have gone clockwise, if I go in this direction, that would be a negative angle measure. All right, so again, positive angles rotate counterclockwise. And negative angles rotate clockwise. All right, let's move up a little bit. Okay, so let's graph a few angles. So again, when we graph an angle, we have our vertex right here at the origin. Our initial side will always be on the positive x-axis. We think of that as 0 degrees. When we do a full circle around, that's going to be 360 degrees. If I remember, a circle has 360 degrees in it. So a fourth of that would be 90 degrees, half of that would be 180 degrees, 3/4 of that would be 270 degrees. So if I'm going to graph 40 degrees, I start with this side right here on the positive x-axis. I go counterclockwise about 40 degrees. So this would represent a 40-degree angle. All right, if I'm going to do negative 40, again, I have to start here with my initial side on the positive x-axis. And this time, because I'm going to have a negative 40-degree angle, I'm going to go clockwise about 40 degrees. And so this would represent a negative 40-degree angle. 400 degrees, again, start here on the positive x-axis. And because it's a positive 400 degrees, we're going to go counterclockwise. A full circle is 360, and then I'm going to go another 40 degrees past that, which puts me right here. So that would represent a 400-degree angle. Negative 400 degrees, again, start here on the positive x-axis. Because it's negative, we're going to go in the clockwise direction, a full circle, and then another 40 degrees past that. So that would represent a negative 400-degree angle. All right, another word we need to know is quadrantal. So a quadrantal is an angle that lies on either the x or the y-axis. So if we have a coordinate plane like this, and we have our initial side right here, this would represent a quadrantal because its terminal side and its initial side lie on either the x or the y-axis. So this 90-degree angle right here would be a quadrantal. Another example would be one that looks like this, where we start here on the initial side, and our terminal side is going to be over here on the other side of the x-axis. So this would be a 180-degree angle, which again is a quadrantal. Another example. Start here with our initial side, and if we end up over here, so we do a counterclockwise rotation this way, that's a 270-degree angle, and that's another quadrantal. And there's an infinite number because you could keep going around and around on that circle. All right, let's move on. Okay, coterminal angles are angles that have the same initial and terminal sides. So let's say I start here on this initial side and I rotate counterclockwise in this direction, and I name that angle theta. Well, that angle theta has the same terminal side as an angle if we were to go in the clockwise direction. So if I were to go this way, this angle alpha has the exact same terminal side right here as angle theta. So they're considered coterminal angles. They have the same terminal side. Okay, so another example would be, again, we start here at this initial side. We go counterclockwise this direction. So I'm going to call that angle beta. Or I could have gone in the clockwise direction this way and called that angle alpha. Both of those angles have the same terminal side, so they're called coterminal angles. All right, we're going to start talking about how to do the measure of an angle. So the amount of a rotation from a ray's initial side to its terminal side is how we measure an angle. We can measure an angle in either degrees or radians. Radians are more exact, so you need to know how to do both of them. All right, let me move this up a little bit. Okay, one thing you need to know is what exactly a radian is. So a radian is if you take on this circle the radius right here, which I'm just going to call r. 1 radian is when that radius and this arc length right here are the same. That would represent 1 radian. All right, so let me erase that. I also think you need to know that the radian measure of 1 full revolution, 360 degrees, is the same thing as 2 pi. So if we start here at 0 degrees and we do 1 full circle around, we know that that's 360 degrees, or it's also considered 2 pi. So let me erase that. So as far as degrees go, 1/4 of a turn would be 90 degrees. Well, 1/4 of 2 pi would be pi over 2. So this quadrantal right here would be 1/4 of a full circle, so it's pi over 2 radians. So we call this quadrant right here quadrant 1, and all of the angles within that quadrant are between 0 radians and pi over 2 radians. All right, if we go another quarter, this would be 180 degrees or pi radians. So everything in quadrant 2 right here would be between pi over 2 radians and pi radians. Down here in quadrant 3, this quadrantal right here, when I do this rotation, this would be 270 degrees, or we would say 3 pi over 2. So everything in quadrant 3 is between pi and 3 pi over 2. And then in quadrant 4, these are all the angles. This is quadrant 4. These are all the angles that are between 3 pi over 2 and 2 pi. All right, so now I want you to kind of think about where 1 radian would be. So let's draw our x and our y-axis. And I want you to think about the fact that this is 0, this is pi over 2, and this is pi. And if you think about what pi is as a number, pi is about 3.14. And then half of that would be, it would be about 1.57. So 1 radian would be in this quadrant 1 right here. 3 radians would be over here in quadrant 2. 6 radians, remember 2 pi would be about 6.28. So 6 radians would be about right here. All right, so let's move on a little bit. Oops, I just realized I didn't answer the second question. It asked us to compare 2 pi radians to 2 radians. So let me change my pen color here. So 2 pi radians is going to be right here after you do a full circle, whereas 2 radians would be a little past this 1.57. This would be just 2 radians. So another thing I want to make sure you understand is that if we just say, an angle that's 2 degrees, that degree symbol lets us know that the angle is measured in degrees. If I just write 2 and I don't write anything with it, that's understood to be radians. And 2 radians, again, would be right here in quadrant 2. That's where the terminal side would end up. All right, let's move on. Okay, we need to be able to convert between degrees and radians. I want you to remember that 360 degrees is the same thing as 2 pi radians. Or 180 degrees is the same thing as pi radians. So the way we're getting this conversion here is that if I divide both sides by 180, I'm going to get that 1 degree is the same thing as pi over 180. So that's how we're getting these conversions right here. Oops. Okay, so I'm just not sure exactly where that left off, but this is our conversion right here. Sorry, my program kind of timed out there for a second. Okay, so this is what we're going to use to convert these. All right, they want us to sketch these angles in standard position. So we have our x and our y axis. And again, think of this as 0 degrees right here. This is 180 degrees. This is 90. So 100 degrees is going to have a terminal side about right there. So this would represent a 100-degree angle. So remember, this is quadrant 1. They're asking us to determine the quadrant that it lies in. This would be in quadrant 2, so it lies in quadrant 2. All right, so now let's do it with radians. We're going to do a negative angle, so that's something to think about, and it's negative 4 pi over 7. So drawing my x and my y-axis. And then remember, this is 0. This would be a negative pi over 2. This would be a negative pi. And this would be a negative 3 pi over 2. Okay, we've got a denominator of 7. So I'm going to think of this negative pi as a negative 7 pi over 7. So a negative 4 pi over 7 would be about right here in this quadrant. So we've got an initial side and then a terminal side. Oops, right here. So that would represent a negative 4 pi over 7. If we did 3 pi over 5, okay, so again, we're doing a positive angle this time. So this is 0. This is pi over 2. This is pi. But if we want to have a common denominator with that 5, this would be 5 pi over 5. So 3 pi over 5 is going to have an initial side here and a terminal side about right here. So that would lie in quadrant 2. All right, let's convert some angles. Before we convert some angles, I'm going to go back to this for just a second. I want to make sure that you understand, that it's past this pi over 2. So if I got all of these to have the same common denominator, they would have a denominator of 10. I could make 3 pi over 5 with the denominator of 10 by multiplying the top and bottom by 2. So that's the same thing as 6 pi over 10. Well, this pi over 2 right here, this is the same thing as 5 pi over 10. So 6 pi over 10 is a little bit past that 5 pi over 10. I probably should have said that while ago, sorry. Okay, now we can move on to converting. Okay, remember from up above we said that 1 degree was the same thing as pi over 180 degrees. So if I'm going to convert 60 degrees, I'm going to multiply that by pi over 180 degrees. And the point of doing that is because this way these degrees are going to cancel out. And so when you multiply that straight across, you're left with 60 pi. Remember, this is understood to be 60 over 1, and you just multiply straight across. So 60 pi over 180, and then simplify, that becomes pi over 3. So 60 degrees is the same thing as pi over 3. 320 degrees, if I multiply that times pi over 180 degrees, again, that's so that your degrees cancel out, you're left with 320 pi over 180. And then when you simplify that, I'm going to knock the zeros off, so that gives me 32 pi over 18. And then both of those are even numbers, so it simplifies even further. That would be 16 pi over 9. All right, negative 30 degrees. So multiply it by pi over 180 degrees so that your degrees cancel out. So you've got a negative 30 pi, don't forget the negative, over 180. And then that equals a negative pi over 6. All right, let's go convert from radians to degrees. All right, so our notes up above said that 1 radian was the same thing as 180 degrees over pi. You know, that's understood to be pi radians, and that way when you convert, you'll be canceling out that radians. So you can think, to convert this, you're going to multiply that by 180 over pi. The pi's are going to cancel out, and so you're left with 180 over 6, which is 30 degrees. Another way to do a problem like that, well, I'll say that in a second. Okay, so let's do this next one. We're going to multiply this by 180 over pi to convert the radians to degrees. So your pi's are going to cancel out, and you're left with 180 times 5, which is 900 degrees, over 3. So that's a 300 degree angle. All right, and then if we convert 3 radians, so if we multiply 3 times 180 over pi, we're going to get, when we multiply that straight across, 3 times 180 is 540, and then divided by pi. And that would be our answer in radians. So if I had wanted to get that as a decimal, that would be about 171.887. This is an exact answer. This would be an approximate answer. All right, let's move on. Okay, now we're going to do notes over finding coterminal angles. So remember, these are angles that have the same initial and terminal sides. So like, for example, using this coordinate grid over here, if I have this angle right here, this is a coterminal angle with this angle. So I could have done, you know, just the first little part right there, or I could have done a full circle, or I could have done even more circles. It has an infinite number of angles that's going to have that same initial side and this same terminal side. All right, so let me erase all that. Okay, so to find coterminals angles in radians, add or subtract 2 pi from theta. 2 pi represents 1 revolution, which puts the new angle in the same position. So for degrees, you're going to add or subtract 360 degrees, which also represents 1 full revolution. Okay, so for example, 0 and 2 pi radians, you're going to add or subtract 2 pi, and you need to have a common denominator. Okay, so for example, if you're going to find a coterminal angle with pi over 6, you're going to start with pi over 6, and you're going to add 2 pi to it to get another coterminal angle. Well, those don't have a common denominator, so you need to make 2 pi have a denominator of 6. So that means I need to multiply the top and bottom by 6, so that becomes 12 pi over 6. So you're really going to be adding pi over 6 plus 12 pi over 6, which gives me 13 pi over 6. Okay, so let's do some of these. Okay, so on this one, they're asking us to find 2 coterminal angles. And the important part right here for you to understand is that they want 1 positive and 1 negative. So you literally need to see one of them is positive and one of them is negative. Okay, and remember, if you're doing degrees, that's when you're going to add or subtract 360 degrees to that to get some other coterminal angles. So I can do 36 degrees plus 360 degrees, and that would equal 396 degrees. That would be a positive coterminal angle, one of many. If I wanted to get a negative, I could subtract 360 degrees. So 36 minus 360 would be negative 324 degrees. And that gave me a negative value when I subtracted those, so I can stop right there. I have 1 positive and 1 negative. Okay, on letter B, we're going to take this negative 210 degrees, and I'm going to get another coterminal angle by adding 360 degrees to that, which gives me 150 degrees. So that would be one positive coterminal angle. So let's get another negative one by subtracting 360 degrees. And when I do that, I get a negative 570 degrees. So what that means is negative 210, 150, and negative 570, they all have the same terminal side. All right, now let's do some when they're in radians. So when you're in radians, you're adding or subtracting 2 pi. But you're going to have to get a common denominator if you have something like 9 pi over 4. So when you add or subtract 2 pi, what you're really wanting to add or subtract is going to be 8 pi over 4, because that's the same thing as 2 pi. So you're going to do 9 pi over 4 plus 2 pi over 4, which gives you 11 pi over 4. So that would be a, sorry, I was thinking about that. I realized I wrote that wrong. I didn't mean 2 pi over 4. That should be 8 pi over 4, which would mean this number would be 17 pi over 4. Sorry about that, because we're adding 2 pi, which is that 8 pi over 4 to that. So this would be a coterminal angle, and then I'm also going to subtract 8 pi over 4. When I do 9 pi over 4 minus 8 pi over 4, I get pi over 4. Now that is a coterminal angle to 9 pi over 4, but again, my directions up here said to get one positive and one negative. I've already found a positive with that 7 pi over 4. I found another positive with pi over 4. I need a negative, so I'm going to subtract again. So it's like I've gone around the circle one more time. And when I do that, I get a negative 7 pi over 4. So that would be an example of a negative coterminal angle. All right, now we've started with 5 pi over 6. So when we add or subtract 2 pi to that, what I'm really adding or subtracting is 12 pi over 6. So we start off with negative 5 pi over 6 plus 12 pi over 6, which gives me 7 pi over 6. That's a positive coterminal angle. To get a negative one, I'm going to subtract 12 pi over 6, which would be a negative, oops, sorry about that, would be a negative 17 pi over 6. So each of these represent coterminal angles that have the same initial and terminal sides. So a given angle has infinite coterminal angles, and the reason why is when you draw your x and y axis, if you've got this terminal side right here, you could go around this circle an infinite number of times and still land on that same terminal side right there. So that's why there's an infinite number. Okay, let me reiterate, if no units of an angle are specified, so there's no degree notation, you know, like if we have 30 and we have that degree symbol right there, that's a degree notation, then radian measure is implied. So if we say something like this, theta equals 2, that means it's just 2 radians because we didn't put the degree symbol on it. Okay, now we're going to talk about arc length. So remember, arc length is the length of an arc with a given angle theta right here. So it's like a portion of that whole circle's circumference. And if you remember your formula for circumference, it's 2 pi r. In geometry, you would have learned how to figure out what the arc length is by doing theta divided by 360 times 2 pi r. So we were figuring out the circle, a fraction of the circle, and multiplying that by the circumference. Well, remember that 360 degrees is the same thing as 2 pi. So when you multiply those out, the 2 pi's cancel, and so your arc length is just theta times r. So that's where they're getting this formula right here. They say S, which stands for arc length, equals the radius times theta. And when we do this, though, the angle must be in radians before we can use this formula, and that's because I converted this 360 right here to 2 pi. All right, so let's do an example right here. We've got a circle that has a radius of 27 inches. It wants us to find the length of the arc intercepted by a central angle of 160 degrees. So using my formula, S equals R times theta, the problem is this is in degrees, so I've got to convert it to radians. So 160 times pi over 180. That way my degrees will cancel. I'll get 160 pi over 180, which is going to simplify to be 8 pi over 9. So when I use my formula, I'm going to say the radius times 8 pi over 9. 9 goes into 27 3 times, so that simplifies to be 24 pi, and my units are inches. Whenever you do arc length, your units will always be something like inches or feet or centimeters or something like that. Okay, now we're going to talk about area of a sector, which is represented right here in this circle, where you have a circle with this radius right here. And our formula that we use for that is area equals 1/2 radius squared times theta. Theta must be in radians again to use this formula. We did this in geometry as well. Okay, so let's look at an example right here. A sprinkler on a golf course is set to spray water over a distance of 75 feet. So my radius is 75 feet. And it rotates through an angle of 135 degrees. So again, we're going to have to convert that 135 degrees into radians. So we're going to multiply it by pi over 180 degrees. That way our degrees will cancel out. So we're left with 135 pi over 180, which simplifies to be 3 pi over 4. All right, so now if we're going to find the area of the fairway watered by the sprinkler, we're going to use that formula. Plug in what we know. So my radius is 75, and I'm going to square that, and I'm going to multiply that by theta, which is 3 pi over 4. Okay, so multiplying that out, 1/2, 75 squared is 5,625. Multiplying that by 3 pi over 4. And so when you multiply that all out, I'm going to go ahead and do the 1/2 and the 3 pi over 4. That multiplies to be 3 pi over 8 times that 5,625. So if I multiply the 3 pi times the 5,625, I get 16,875 pi over that 8. And then if you were to convert that to a decimal, it would be approximately 2,109.375 pi. And then our units were feet squared. So that would be your answer. Okay, thanks y'all. I appreciate it.